Good morning, mathematicians. It's Mrs. SJ here for our live math lesson. Today we're going to be talking about mixed numbers, continuing our discussion from yesterday, and what improper fractions have to do with mixed numbers. So double check that you have your materials that are found right over here. I am going to say that having a whiteboard and an expo marker absolutely proves useful for doing some quick math. However, when we're taking notes for anything that we're learning for the first time, it's really helpful to have it somewhere that you can go back and always refer to. Especially when you're coming to small groups. Come to small groups prepared with your lessons. Shout out to those who've been showing up to the math small groups with their notes from the lesson. Now below, you're going to see our teaching point for today. It's a bit cut off at the end, but no worries, I'll read it to you regardless. Today, your teaching points are, I can identify what an improper fraction is. Say it with me. I can define and identify what an improper fraction is. The second teaching point for your day, for our lesson today, is I can use division to convert an improper fraction into a mixed number. Well, let's remind ourselves that yesterday we defined a mixed number as a representation of a whole number and a fraction. Now, when we're thinking of defining what a improper fraction is, well, part of defining this is actually examining what an improper fraction is and how we convert it into a mixed number. Why do we call it improper? Is there such thing as a proper fraction, right? Absolutely, there are, and we are going to really consider that a improper fraction and a mixed number are very closely connected. Oftentimes they are the same thing. If I represent a mixed number, right? For example, if we use 1.5, let's use this half to really look deeply as to what makes an improper fraction. So on that note, join me as we take a look at these numbers. Now, to start off with any fraction, and like I said before, we're going to use 1/2 as our focal fraction for today, to really examine how does an improper fraction show up. Well, if we have 1/2, okay, thinking back to regardless if we're using circles or strips or any other visual representation to show us a fraction. Well, I know that if we're using a half, that means that I'm cutting whatever representation I'm using in half. Whether it's 1, or if I have 2 wholes and I cut them in half. If I have 3 wholes and I cut them in half, and so on and so forth. We could really show this using any number, even beyond 10, right? We can count forever and cut all those numbers in half. And really, we're not doing anything. We're not adding, we're not subtracting. We just want to show how many halves are in these whole numbers. And so within 1, we have 2 halves. If we have 2, and we want to figure out how many halves are in here, well, let's count. We have 1/2, 2 halves, 3 halves, and 4 halves. Keep going with me. Let's count. Let's see how many halves we have with 3 holes. 1/2, 2 halves, count with me, 3 halves, 4 halves, 5 halves, and 6 halves. And we can do this, to borrow a phrase from Mr. Taco, until the cows come home, right? We could keep on going. I really like this, what we're noticing here. Now, take a look at these different equations. Once we have more of the pieces than there are of how many times we've cut it up, this is when it becomes an improper fraction. Oops, it's not ending. That was an accident. So here, I want us to take a look at this because something kind of special is happening here. You know, when we have more pieces than there are of how many times that initial whole was split up, right? We've split up this one whole into two pieces, but we don't just have one whole, we've got two wholes, or we have three wholes. Here is where a fascinating connection is, because I want to start making sense of this by reminding myself of what we already know, because in your head there's something happening here. 3 wholes is equivalent to 6 halves. Where have you seen these 3 numbers before? Consider. If 6 halves equals 3, where have we seen these numbers connected before? Well, if I multiply 2 times 3, that gives me 6. What about 6 divided by 2? What does that equal? And I want to remind us that, you know, for those of us who are here and are responding in the chat, I am so glad that you're here. Please remind yourself to use the garbage can tool for anything else that is not keeping you present for this live meeting, for this live lesson, okay? So thank you to those who are here. I am going to be looking for people who are participating and answering my call and response in the chat. Now, we've made this connection here. 6 halves is equal to 3. Well, what are we doing here? 6 divided by 2. Does 6 divided by 2 also equal 3? Absolutely. Well, let's keep on seeing if this statement can prove to be true as we move along. What about 5? If I have 5 wholes and I want to see how many halves are in these, right? I'm going to set it up by cutting each of them in half. And if I have 5 halves, let's see, or excuse me, 5 wholes that are cut in half. How many halves will I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 halves. 10 halves is equivalent to 5. Well, what is actually happening here? What is 10 divided by 2? That's right. It's 5. Is a division symbol, excuse me, is this fraction line related to the division symbol? Consider, fractions are when we divide up a whole into equal parts. I wonder if this will be true if we opt to represent these not with 1/2 but with 1/3. I want to see if this is actually going to continue to be true. If we decide instead of 1/2 to split these up, what if we split them up into thirds? Now, I'm going to use a different color marker to represent this. So if I wanted to do 1/3 instead, okay, and that means that I'm going to have to, I would represent these by cutting them up into what? Thirds. Let's see if this represents what we're talking about. I'm going to skip down and show this on fourths as well. Now go ahead and work along with me in trying to represent these. Now notice that the whole itself hasn't changed. What has changed is how many times we've cut it up. So this is where our denominator changes, right? We now have 1, 2, 3 pieces, and we want to represent this by showing that we are using up all 3 pieces. So this is also being shown as 3/3. What about if I have 2 wholes? How many thirds are there? Well, I have 1/3 plus 1/3 plus 1/3 plus another. That's 4/3, 5/3, 6/3. Let's also do this with 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, keep on going, 10, 11, 12 thirds. What makes 6/3 and 12/3 an improper fraction is that there are more parts than how many we've split it up in. And so I want us to make this connection that this division symbol, which is representing that we have 12 pieces that have been split into thirds. So how many wholes do we have? Well, what's 12 divided by 3? That's right, 4. Absolutely. And so we could represent this in, like Mr. Taco said, we can represent this until the cows come home. We could see how many times we can split, or how many pieces there would be if we had 6 or 66. That would be quite a bit. We could do 1,000 and see how many pieces of thirds are there in 1,000 wholes. Now, we don't have time for that, but I wanted us to see that there is a connection here. Regardless of how many times we're cutting up our fraction, this is one way that we can identify an improper fraction, is when there is more parts than how many times it was split up. Now, with this, I kind of want us to try out another strategy after using this as a way to deepen our conceptual understanding. So, when we're considering a mixed number, and when we're considering a improper fraction and how to use division to represent or to convert a improper fraction into a mixed number, right? We want to turn our improper fraction. We want to convert our improper fraction into a mixed number using division. So with that, let's take another improper fraction. Let's take 11 thirds. Well, another way of thinking about this is telling ourselves, okay, well, I can represent this by figuring out how many wholes are there and how do I turn this into what I need to. Well, in so many ways, this is telling me that I have 11 pieces and I need to see how many groups I can make of 11 into 3. How many groups of 3 can I make? Well, one way that I can show this is by a strategy that we've all used before with division, because we're really just making groups. Fractions are, in a way, making groups. So I'm going to draw 11 dots on here. And I want us to see how many groups of 3 can we make. 1, 2, 3. Well, I have 2 left over. Now you might be thinking, okay, well, how does this show me how my improper fraction can be represented in a mixed number? This is another way that we can do this. In a way, these dots are 1/3. Let's count together. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, and 11/3. These are all parts of this fraction. The denominator is not changing. We are trying to see how many groups, how many thirds out of 3 that we're making. Each time I'm circling, that's 3 out of 3. So if I know I have 3 out of 3, that equals 1. And if I have 3 out of 3s, that's going to equal 2 wholes. If I have another group of 3, that is a 3rd whole, right? So I have let me represent this, let me show this in a different way. I have 3/3 plus 3/3 plus 3/3. And from our previous discussion, we know 3/3 is equivalent to 1 whole. So 1 plus 1 plus 1 is 3. Now, we have some stuff going on. If I was going to represent this by just showing 11, what's 11 divided by 3? Well, many of you would write this as 3 remainder 2. In fractions, the remainder 2 tells us of how many thirds are left. We have 2/3 remaining, right? This is where that 2, we have 2 pieces remaining. But we're not done. Because this is how we would represent it if we were just doing a plain old division equation. But we're trying to turn this into a mixed number. So it's not going to be 3 remainder 2, because these are 2/3, right? We have 1/3 plus 1/3, which equals 2/3. We have now converted our improper fraction of 11/3 to a mixed number of 3 and 2/3. There's another way to represent this. Absolutely. We can use older and dependable strategies that you learned for division. Now remember I said in 4th grade that I'm not usually a stickler for memorizing certain facts, but your multiplication and division facts are vital or crucial to making sure that you are going to be able to do some really good fraction work, especially when we're converting improper fractions to mixed numbers. There's a lot of connections here to multiplication and division. And this is why I love fractions so much and using this old strategy. Now, could we also draw 11/3, just like how I had before with a drawing circles or even pies, circles or fraction strips? Absolutely. I could see how many times I can get, how many thirds there are if I can count up 11/3. So I know that one of these, that's 1, 2, 3 thirds. 4, 5, that's 6 thirds. I want to make sure you can see this. 7, 8, 9. We're almost there. 10, 11, 12. But do I have 12 to give? I don't. I don't have 12 to give out. Now, this is where fractions, decimals, division is so useful. This also reminds me of times when I was old enough to first start going to the corner 7-Eleven when I was in middle school. And I would have a certain amount of money. And the thing is, I couldn't spend what I didn't have, right? So if I had a $10 bill and something cost $10.25, well, I didn't have that extra 25 cents, so I wouldn't be able to afford it. So really, I wanted to make sure that whenever I was going out and buying something, that I was looking at my kind of cutoff point. Like, I know that I don't have enough to get that whole other thing. Do we have that third to make 4 wholes? We don't, right? We only have 11/3. So we're missing that 1/3. And if I was going to represent this, well, I know if I have 3/3, that's 1 whole, plus 1 whole, plus 1 whole, plus I don't have a whole. I have 2 parts of this whole. 1 plus 1 plus 1 plus 2/3 equals 3 2/3. Could you represent this as a fraction strip? Absolutely. Now, what I'd like for us to do is move along and look at a few other numbers, okay? I want us to look at a few other numbers. And if you're panicking because I just erased all of this, the wonderful thing about crisis distance learning is you can always rewind, you can go back. Now I want us to look at a bigger improper fraction. Let's use 23 over 4. Well, that first strategy I showed us is, let's draw out 23 pieces. Okay, so go ahead and count with me. I'm going to go by 5s just because that's going to be easier for me. I want to see how many groups of 4 I can make. Now, these aren't 23 pieces. These represent a fourth, right? I have 1/4 plus another fourth equals 2/4, 3/4, 5/4, and so on and so forth, right? These represent a fourth. I want to see how many wholes I can make because I know that 4/4 equals 1 whole. So count with me. We've got 1 whole plus another plus another plus another plus another, and I have 3 left over. So my improper fraction is going to be 1, 2, 3, 4, 5 wholes. Remember, the denominator stays the same, right? This is 1/4 plus 1/4 plus 1/4. So what is my remainder? It is 5 3/4. Another way I can look at this is, what is 23 divided into 4 parts? We're trying to see how many groups of 4 we're making. If this was a regular old division problem, it would be 5 remainder 3. Look at this. 5 remainder 3. But this isn't a regular old division problem. The remainder 3 is referring to there are 3 out of 4 parts left over. Would I be able to afford something that cost $6? No, I don't have that extra fourth to get me something that's worth $6, right? We do not have a whole number yet to get to 6. Excellent. Now, this is one way to do this. Could you do this another strategy? Absolutely. Let's try one more. Okay? Really making this connection that we are using division strategies that we learned in 4th grade to help us with solving improper fractions. Okay? Now, this is also really interesting, right? We can do really big numbers if we wanted to. Let's take 13 over 5. 13 over 5. Well, we would set this up by making 13 pieces. And we are trying to group them into how many, what groups of? Groups of 5. So let's count and see how many groups of 5 we can have left over. Many of you are starting to make this connection. Oh, well, I know that there are going to be at least 2 groups of 5, because 5 times what is going to get us close to 13. Well, why wouldn't 5 times 3 work? Why wouldn't there be 3 whole groups? Because 5 times 3 is 15, right? If I have one, here's one group of 5. Here's another group of 5. And I have 1/3, 2/3, 3/3 left over. So this is going to turn into 2 and 3/5. 13 over 5 is equivalent to 2 wholes and 3/5. We know this because we just proved it, right? Absolutely, improper fractions and mixed numbers can be equivalent to one another. And we just proved it. 13 over 5, or 13/5, is equivalent to 2 and 3/5. Absolutely. And really we're thinking, well, it's because I have 2 groups of 5. I know that that equals 10, right? Plus my 3 parts. Right? I have 2 groups of 10. So then 10 plus my 3 parts is going to show me how many pieces I have in total. So with that, I am going to say I would love for your guided practice to be to show me what's another way you can turn 13/5 into an improper into a mixed number. And what is an additional way you can convert 23/4 into a mixed number. I will also be adding additional practice time, but I'm going to post the extension task to Google Classroom very shortly. So if you finish your exit ticket, you will continue to do work either on the extension or ST Math. So with that, have a lovely day. And if you need more support, I will be on our Zoom for office hours. All right, kiddos. See you soon.